What's up, math scholars? It's St. Patrick's Day. Everyone's wearing green. Well, I think like maybe 6 people are wearing green. But we're pretty happy. It's going to be a sunny day and a warm day. My microphone keeps twisting backwards. I might have to flip it better. But we are going to do a study guide video today in preparation for the next quiz. It's going to be Polaris only, though. We will provide the formulas to you, so you don't need to memorize formulas. That's good. Accelerated students, you're going to be using a non-graphing calculator only. On-level students, you can have the graphing calculator. Okay? Who's excited? Woo! Yeah! All right. So let's start with number 1. We are being asked to graph the sequence. One piece of advice I have for you is just realizing that the numbers in the sequence are kind of like the y values or the range. And the numbers that are invisible above them, you have to assign these numbers. That's the x value or the domain. Now when I go to make the graph, it's not going to make a straight line looking at those values, but you don't want to connect the dots. So when you go to 1, 2, and you make a dot, 2, 5, make a dot, 3, 10, make a dot. I'm out of space, I'll stop there. Don't connect the dots. It's a discrete data set. You don't have decimals in the domain. You can't have term 1.8, so we're pretty much done there. Did any group successfully come up with the equation of the sequence? Georgie? Perfect. Good job. Number 2, my last class was getting hung up on thinking this was arithmetic or geometric. It doesn't have to be arithmetic or geometric. You just have to be able to find the pattern. Do you see a pattern developing here, and do you know what would come next? Dick?
7 over 9.
Good. So the next term would be 7 over 9. Now I'm going to go ahead and assign those x values like I always like to do, because that will help me figure out my formula. My formula is going to have a fraction to it, because the top and the bottom will kind of have like different equations. To turn a 1 into a 4, a 2 into a 5, and a 3 into a 6, I would do n plus 3. And then to turn a 1 into a 6, turn a 2 into a 7, and turn a 3 into an 8, I would do n plus 5. Does that make sense? It's not really arithmetic or geometric necessarily. All right, to make my first 4 terms, I always like making these charts. It's just how I do my life. So I'd go term 1, term 2, term 3, term 4. You can fill it out with your mental math. I was going to say, or you could use the table. Well, you're not going to have the table available on the quiz, so I guess we're doing mental math. 6 minus 4 times 1, that would be 2. 6 minus 4 times 2, so 6 minus 8, negative 2. 6 minus 4 times 3, so 6 minus 12. Yep. And 6 minus 4 times 4, so 6 minus 16. Good. And these are the actual terms themselves. So these are the terms. These are just the domain that helps me get my range. This is probably the most challenging one we've come to so far, because I know this is term 2, I know this is term 3, I know this is term 4, I know this is term 4. 1, 2, 3, 4. Okay, but I don't know what term this is, and I kind of have to figure that out because we're writing it in summation notation. So I know I'm going from 1 to something, and I don't know what term the 41 is. I'm going to go ahead and think about the pattern. How much are we going up each time? It's a constant slope. 3n. So 3n is going to be my slope. And then I just like figuring out what term 0 is, because that would be my y-intercept. What's term 0 going to be? An 8. So it's 3n plus 8. And you can check just by maybe putting a 4 in and making sure you get a 20, and it works. What's a 4? It just looks weird. So now that I know the formula, I can figure out what 41 is. I'll set 41 equal to my 3n plus 8. I'll solve it. If I subtract the 8 over, what is that, 33? Divide both sides by 3. So 41 is term 11. So term 11 is where this sequence stops. Ta-da! But they don't actually want me to find the sum, so I think I'm done. Okay, so we're just going to use the charts to show our work and find the sum. We're going from term 4 to 9. So 4, 5, 6, 7, 8, 9. These are my terms. Do I have a group that's got this filled out and they can go ahead and just tell me the numbers? Any group filled this one out yet? Not yet. I'll give you a second. Go ahead and fill it out with your partners and we'll pause it and give you work time. Okay, I got my chart all the way filled out. And now what we want to do is take the actual terms themselves and add them together. And that will be your overall sum of these series. I'll give you a second to add on, but I got 223, so just check that you get that same answer. All right, number 6. This is going to be a bunch of fractions. Term 1, term 2, term 3, term 4. I'll just use mental math here because I'm pretending I don't have table world. It would be a 1 on top and a 4 on bottom. You agree with that? It'd be a 2 on top and a 5 on bottom. It'd be a 3 on top and a 6 on bottom. I could reduce that to 1/2. I'll leave it. And then it'll be a 4 on top and a 7 on bottom. Does that look okay? Just checking real quick. Yep. And now we got to add them all up. It's going to be a pretty yucky decimal, so you could fraction it if you want. I got 241 over 140. So take a second and make sure you match me on that. Number 7, our last one where we're filling out this chart. Term 2, term 3, term 4, term 5, term 6. We have to cube the number and add 8, so some of these start getting a little bit big. 2 cubed is 8, plus 8 is 16. 3 cubed is 27, plus 8 is 35. 4 cubed is 64, plus 8 is 72. 5 cubed, 125, plus 8, 133. And 6 cubed is 216, plus 8, 224. I get to add. She got 480, but go ahead and check me. I'll give you a second. All right, again, these shortcuts will be provided to you. They are up on the board, but I'm going to copy them out on a little slip of paper. For right now, I don't think on the paper I have them labeled, but for right now, I'll just show the kids at home. I have them all labeled, like shortcut 1, shortcut 2, shortcut 3. So people at home might hear me calling them shortcut 1, shortcut 2, but I'll write down what shortcut it is. All right, people in the room, number 8, do you think it's shortcut 1? You're looking at the formula itself. Is the formula looking right? No. Do you think it's shortcut 2? Yep, so this is shortcut 2. I'll write the formula down so the kids at home can see it. N times n plus 1 over 2 is the shortcut we have determined we can use. Where n is the number of terms in the sequence. So what is n for number 8? Jake?
47.
Yep, good. So it ends up being 47 times 48 over 2. So go ahead and type that in, see what you get. Did you get 1128? Good. All right, do you guys think this is shortcut 1, looking at the formula? No. Do you think it's shortcut 2? Nope. Shortcut 3? Nope. Shortcut 4, which is arithmetic, or shortcut 5, which is geometric. So I guess what I'm asking you is this equation arithmetic or geometric? Someone has to know. Brody. Yeah, it's arithmetic. Jake pointed to you. I just couldn't hear. Okay, so it is shortcut 4 because the formula itself is arithmetic. So here's the shortcut we're referring to. A little bit harder to use than the last one, a little bit more stuff going on. N is the number of terms in the sequence. How many terms are in our sequence? 8. A1 is the first term, which you can normally get by putting this guy, the lower limit, in for H. So what would that be? 12, I think, right? 5 times 1 plus 7? 12. AN is the last term, which you get by putting the 8 in for H. What would that be? 47 over 2. So you're averaging the first and last term, and you're multiplying by the number of terms in the sequence. So 412 plus 47, enter, divide by 2, enter, times 8. I got 236. Is that what you guys got? Okay. What do you guys think the next one is? Shortcut 3. Better believe it. Let me write down the shortcut so everybody at home can see. A little more involved, but pretty much our only decision is what is n. So how many terms are in our sequence? That's n. 27. So 27 times 28 times, I don't know, this is a pretty big number, over 6. Go ahead and type that in and see what you get.
55.
Oh, really? Because I have 6930. Did you do 27 times 28 times whatever big number this is?
Oh no, I was just doing that one.
Oh, okay. This is 55? Wait,
Yeah.
okay, that's 55. So 27 times 28 times 55 over 6. Did you guys get 6930? All right, on 11, there's a lot going on. We have to first write the rule. Do you think this is looking like arithmetic or geometric? Because I feel like that's definitely a decision we need to make. Are they adding a constant amount or multiplying by a constant amount? Yeah?
It's arithmetic because they're adding.
They're adding a constant amount. If you want to use the arithmetic formula on the board, you can. If you want to just do it in slope-intercept, you can. Half the time I end up just doing slope-intercept because it's how my brain works, but I'll do both. So if I'm going to use the formula on the board, A1 would go first, then n minus 1, then d. The constant difference is how much they're adding each time, so 6. Now, if you want to do slope-intercept, because honestly it's polar, so you don't know if the choice will be in this format or slope-intercept format, you can just distribute the 6 and combine the like terms, or here's how I actually do it. The minute I see they're adding 6 each time, I know that's my slope. And then to find my y-intercept, I just have to figure out what term 0 is. So I just work backwards. 10, 4, negative 2, negative 8. What would the next term be working backwards? I agree. So that's my y-intercept. That's just how my brain works, but I guess because I've been doing slope-intercept form for like so many years. This is like a newer thing for me, but this I've been doing since forever. All right, summation notation. I would say that I'm going to be going from term 1 to term 10, and either formula would work here. I'll just do that one. It's a little more traditional. And now we get to find the sum. What shortcut could we use to find the sum of the terms 1 through 10? Shortcut 1, 2, 3, or 4. Izzy just said it, 4. You went like this. Saw you. All right, so shortcut 4. Shortcut 4. All right, so shortcut 4, I'll jot it down so we have it. It's n times a1 plus an over 2. So there are 10 terms. Our first term is negative 8. That's easy. I can get it by putting a 1 in for n, or I could see it, honestly. What's the last term, though? Let's put a 10 in for n to get the last term. 46 over 2. So we're averaging our first and last term, dividing, or multiplying by 10. Negative 8 plus 46, divide by 2 times 10. 190. That is your final on part C. All right, to solve this one, our D was 7, our N was 12, and our AN was 81. And we can use this formula to help us do it. So AN is 81. A1 we're trying to solve for. 7 minus 1 times D. Oops, wait, 12 minus 1. Almost put the wrong number in the wrong spot. 12 minus 1 times D. So we have 11 times 7, which is 77, and we subtract the 77 over. So it looks like everybody that came up to the board got 4 for their A1. And then we do need to express the final answer, which they all remembered to do, which is good to see. It is 4 plus n minus 1 times D.
It's easier.
On this one, we don't know A1 or D, so start by finding D, which is your slope. Once you get your slope, you can pick your favorite XY coordinate. Actually, an AN coordinate, however you want to label it. And you can solve for your A1.
You know how I have
A1 equals 18.
what if those 5 plus 5?
You got 18 too. I was pausing to make sure I matched my neighbors.
So make sure,
And now we express our final answer.
but I don't know how to show the work to you.
A1, N minus 1, D. Now my last class was still a little confused on, yeah, we've been expressing our answer like this, what I have in blue, but how would I get it to slope-intercept form, just in case all the choices are in slope-intercept form? Do you know how to convert?
4 over 8 would be 31.
You literally just distribute that -4, which would make it -4n plus 4, and then you combine your 18 and your 4, so 22. So that one or the other would probably end up being a choice. What shortcut do we think we can use? Yes?
The geometric series finite.
Shortcut 5, finite geometric series. Shortcut 5 looks like this. We just learned it yesterday. Oh, wasn't that funny on Delta Math? They had a different formula than me. I just used the formula in our textbook. Their formula was the same formula, yet looked different. What they had done is distributed the A1 to here and here. So it's the same formula. It just had A1 up here and here and here. All right, let's see if we remember how to use it. A1 is the first term, and you can get it by putting a 1 in for B, just to verify it is what you think it is. It's 5. Good job. And then it's 1 minus R, which is our constant multiplier. What's our constant multiplier? 2? Everybody okay with that? And then N is how many terms there are. There are 14 terms. And then the bottom, 1 minus R again. Can you tell that's a 14? Sometimes I want to make sure my handwriting is like perfect when I save these online. Okay, let's type it in. If you are not going to have the graphing calculator, you're going to have the pink calculator, the red calculator, whatever color it is. I suggest little baby steps. So here's how I would do it on the red one. 1 minus 2 to the 14th. I click enter. Then I would divide it by -1. I did it in my head. Enter. And then I would times it by 5. So did you guys get 81,915? Okay, good. So that just proves it's not a problem on the red calculator. Just do it in little pieces. 81915. Number 15 had a slight typo to what I printed out for the students. It has to be term 1 to 13. I'll have to fix the PDF that I put online. So what shortcut? Shortcut number 5 again. It's still geometric. It's just not infinite anymore. So here's the shortcut. A1, 1 minus R to the N, 1 minus R. So our first term we can get by putting a 1 in for B, so it just ends up being 5 again. It was 5 last time. Then we're doing 1 minus R. The constant multiplier is 4/8. I don't know why it's 4/8. I should have just made that a 1/2. How many terms are in the sequence? 13, very good. And then 1 minus 4/8, or 1/2 again. All right, if I'm using the little red calculator, 1 minus, parentheses, 4/8 to the 13th power, enter, divided by 1 minus 1/2 is just 1/2, so I'm just dividing by 0.5, times by 5. Did you guys get 9.998779297? 9.9988. I'll just round it. Yeah?
I have a question.
Yeah. What shortcut is this one? Dick? It's still shortcut 5. It's still exponential growth. You just can't see the start value. Start value is a 1, invisible 1. So shortcut 5 again. Gosh, we've been doing shortcut 5 for an hour, it feels like. 1 minus R to the N over 1 minus R. So the first term, if I put a 1 in for B. Oh yeah, this might be different. If I put a 1 in for B, is that going to be 4? So first term 4. James, we might need you to check our answer on this one with your secret thing. Okay. Okay, good. All right, good news. I started panicking for no good reason. This formula works out perfectly. We typed it in several different ways, and we got 340 every time. So don't know why I panicked on that. Okay, let's read this one. You start a job that pays $1 the first day. That's your A1. Giving it to you right off the bat. $3 second day, $9 third day. It keeps tripling every day. So our constant multiplier is 3. What will be your total income after working 10 days? So you want the sum of how much you made every day for 10 consecutive days. So it's a summation problem. You want the sum of working from day 1 to day 10 of the geometric sequence, 1 times 3 to the n minus 1. All right, so does that make sense? It's geometric. We're finding the sum of the first 10 days. All right, shortcut 5 again. We've been doing shortcut 5 forever. Shortcut 5 is A1, 1 minus r to the n, 1 minus r. So A1 is our first day salary, 1. Our constant multiplier is 3, and we're doing this for 10 days. So let me just type it in to triple check the answer I've gotten. 1 minus 3 to the 10th divided by negative 2 times 1. $29,524. That'd be sweet to make that much money in 10 days.
Or the
So
total
I'm using
amount.
the geometric formula.
And
I'm
then
putting the
use
768 in for
And then
AN,
R's 4. So it goes there.
solving for
Yeah,
A1, using 4 as my R value, and using 5 as my N value.
I'll figure it out, man. You got what it's 8.
4 to the 4th was what, 64? And then you divide. You guys got 3? Yeah, I got 3. So our final, AN equals A1 times the constant multiplier, the N minus 1. Oh, you gotta leave. Yep. See ya. Hey, just had an in-person learner that does pay attention, and he told me 4 to the 4th is 256, so my work was wrong on this. But I still think that my answer was right. My work was just wrong. Is that right? Okay. All right, so we're going to make ourselves a system of equations. We just learned this yesterday. It's fresh in our mind. This is an n value. This is an an value. This is an n value. This is an an value. We don't know A1. We don't know D. So here goes. Negative 15 equals A1. I meant D. I meant R. I said D, but I meant R. And then 1 minus 1. Oh, crap. We know A1. I guess my brain just wanted a hard problem. This one is so easy. Jeez. We know A1. So all we need is R. So this is an N and this is an AN. Thanks. You're saving me from my own brain. All right. So AN is the 240. A1 is the negative 15. We need to solve for R. And then N is 5. Is that looking better now? We're looking good on my setup? Okay. So I'm going to divide the negative 15 over. Negative 240 divided by negative 15 is 16. And that's R to the 4th. Take the 4th root on both sides, and R is 2. Is that looking good? So we know A1 and we know R. That was easy peasy. I was expecting a hard one. They were all easy. So now our final AN equals A1 times R. All right, last two. I mainly want to talk to you about the graphs and how to come up with the equation, because there is one like this on the quiz. You just kind of want to make an XY chart from the data that you're seeing in the picture. So like this coordinate looks to me like it's at 1, 3. Do you agree? Where's this coordinate look like it's at?
4,
1, 5? Yeah, I think I agree. Wait a minute, that's at 1, 3, so that must be at 2, 5.
Yeah.
Okay, 2, 5. And then 3, 7. This is linear. And then 4. So it's totally linear. It should be easy to come up with the formula. The slope is 2. And what would the y-intercept have been if I worked backwards? 1. Easy peasy. Now next one's not looking so linear, so we might have a little bit more of a challenge. Where's this first coordinate living at? 1, 2. Where's the second coordinate living at? 1, 2, 3, 4. 2, 4. Is it 3, 8? So, what type of equation do we think we're going to have? It's classic geometric, right? The r value is just a 2. So the first term is 2, and the r value is 2. So I believe that's probably our best bet for our equation. Hey, thanks for hanging with me. That was a 26-minute video with pauses. So I know today was a lot, but you helped me so much with getting this video for the e-learners. So